Hi, future engineers! I'm Engineer Micaela Palaganas, also known as Engineer Ella, a chemical engineer and a content creator. In this video, we are going to learn how to utilize Casio FX 570 ES Plus 2nd edition in the identification of thermodynamic properties using double interpolation. Determine the specific volume of water at a state of P equals 0.02 megapascals and D equals 625 degrees Celsius. First, we have to determine the state of water. Using saturated vapor table, we can see that at 0.02 megapascals, the saturation temperature is 60.06 degrees Celsius. Since our given temperature, 625 degrees Celsius, is greater than the saturated temperature, the water is in the superheated vapor region. Now, when we look in the superheated steam tables, we realize that we can find the specific volume at both 0.01 and 0.05 megapascals and at either 600 degrees Celsius or 700 degrees Celsius. But we do not have exact values for P equals 0.02 megapascals. We also have no value for 625 degrees Celsius either. Our unknown point lies somewhere between our two known pressures and somewhere between our two known temperatures. What we need to do is to interpolate between the known temperatures and interpolate between the known pressures. This is called double interpolation. We will put the four known values, the specific volumes, at the corners of the table. Then, we label the rows and columns with the appropriate temperatures and pressures. In this diagram, the answer that we're looking for, the specific volume at 625 degrees Celsius and 0.02 megapascal, is at the center of the square. Here, we could first interpolate using P as the independent variable to find the specific volume at P equals 0.02 MPa at both 600 degrees and 700 degrees Celsius. Then, we would need to interpolate again using T as the independent variable to get the answer. Now, let's do the interpolation using Casio FX 570 ES Plus 2nd edition. The steps are shown here in the diagram. First, press mode and then choose 3 stat and then choose 2 A plus BX. Now, we are first interpolating for T equals 600 degrees Celsius. So, we have for P equals 0.01 MPa, we have a specific volume of 40.296. And for P equals 0.05 MPa, the specific volume is 8.0577. So, we will put those values here. We know that the independent variable is P, so we will put those values in X. So, the first value is 0.01 and the second value for P is 0.05. Click equals and then let's navigate up. Let's input the values for Y. The first is 40.296. Press equals and then 8.0577. Press equals and then let's press AC. Next is to press Shift and Stat and then we will choose 5 reg and then we have to choose the Y hat or number 5 since we are looking for the value of the dependent variable or the specific volume. Now we have to multiply this Y hat by our desired pressure, which is 0.02 MPa, and then press the equal sign. We will get 32.236425 cubic meters per kilogram as our specific volume for P equals 0.02 MPa. Now let's do our interpolation for T equals 700 degrees Celsius. So we will just do the same steps again. So press mode, stat, choose 2, and then let's input these values, 0.01 and then 0.05. Next, for Y, we have 44.911, press equals, and then 8.9813. And then we have to press AC again, press Shift and Stat, and then select Reg 5, and then select Y hat again. Multiply that by our desired pressure, which is 0.02 MPa, and press equal sign. We will get 35.928575 cubic meters per kilogram as our specific volume for T equals 700 degrees Celsius and P equals 0.02 MPa. Now that we have our specific volume for T equals 600 degrees Celsius and T equals 700 degrees Celsius at P equals 0.02 megapascals, we can now get the specific volume at T equals 625 degrees Celsius by interpolating between our temperature and specific volume. So let's do that again. It's just the same process. First, press mode, stat, and then choose A plus Bx or 2. And then input the value of temperature at the independent variable x. So that's 600 and 700. And let's go to y. So we have our corresponding values, 32.236425 for 600 and 35.92575 equals, and then press AC, and then after that press shift and stat, select 5 reg, and then choose Y hat. Since our desired temperature is 625, we will multiply it by Y hat, press the equal sign, and we will get our desired specific volume at 625 degrees Celsius and P equals 0.02 megapascals. We get 33.159 cubic meters per kilogram. That's it for today's video. I hope that you learned how to use your Casio FX 570 ES Plus 2nd edition for thermodynamics problems. Thank you very much and see you on our next videos.